Oh, yes.
Where's Rachel? Where is she? Where'd you... Harvey? Where did you put her? Where did Harvey put Rachel? Hello. You're watching Nerdish. I lost my shoe. You gotta put your shoe back on. Very good. What are we doing here? Well, we do SAT, ACT prep for everyone. Yes, and the question is not where is Rachel, but when. 8 to 9:30 p.m. That's when Rachel is. Tuesday, Wednesday, and Thursday. Watch it. Just see what it's like. It's for free. All week long. You can ask us questions like where's Rachel and what you do with Rachel and where is Harvey Dent. They're both studying for the SAT. It's a very important test if you want to go to college or university. Nice. I should have said university first because it rhymes. Oh, that's Catwoman. That's okay. I think we know Catwoman because we're Batmen. Let's do a problem. Yeah. We did exponents last time. What should we do? Let's factor a quadratic. Okay. Man, when it comes to education, I'm an addict. Oh my God, but not that kind of addict. No, just a quadratic addict. I hope this is factorable. Oh, it's gonna be factorable. Add 6. Okay. 6 is for Rachel. All right. Let's take out a 2. Let's make it equal to 0. That's a good idea. Okay. So let's factor out 2. X squared minus 2. How much time do we have before Rachel explodes? Ask Harvey. Harvey. Multiply to positive 3, add to negative 2. I don't think that's possible. Oh, shoot. That's okay. Sometimes you can't factor quadratics. And sometimes you can't save Rachel. I was about to say that. I'm so sorry. No, it's good. It shows that we're tight bonded. Like tight bond. Original wood glue. It has a tight bond. Like me and Levi.
Welcome to the stream.
Yes, here we are.
What do you think of that intro video,
Everybody thought nothing of it.
Yeah, apparently no one's watching.
It's nothing.
It's fine.
It's
It's nothing but a thing.
Yeah.
That's all it is.
It ain't no thing.
Right. It ain't no thing.
Yeah.
Hey, what are we doing today?
Well, Exponents.
Right. I'm a proponent of
exponents. Yes.
We didn't plan that.
Nope.
We just have chemistry.
Chemistry.
And physics.
And exponents.
And biology. And lots of exponents that we keep out back.
Yeah.
Yes.
Speaking of, you should bring them out.
You think so?
Yeah.
All right, let me go grab them.
Yeah. Oh, there they are. Great. Okay, now go do the exponents.
Oh, all right, fine.
Yeah.
All right.
Why don't you do the easy stuff, and then I'll deal with the harder stuff.
Sure.
Yeah.
Yeah, that's a great division of labor.
Right, I think so too, because you
Right.
can't do,
I can't do the
other
hard
stuff.
stuff.
So you're welcome.
Right, we're gonna leave it to you.
Right.
I'm so glad that I'm working with you.
You should be that.
Oh, man.
All right.
Exponents.
Exponents, robots in disguise. That's what exponents actually are. They're robots, but they're in disguise. Yeah. You look up in disguise, they're up there. All right. Very good. All right. So, guessing you probably know what an exponent is, but if not, let's talk about it for a second. All right. So here's an easy one. X times X times X times X. That's 4 X's in a row, all right? Not too many, but it gets annoying here. We have notation to simplify repeated multiplication, and that is exponents. X to the 4th power means X times itself 4 times, like that. I mean, I guess it's really times itself 3 times because there's 3 multiplications, but there's 4 X's, and that's the important part, okay? Very good, very good. So let's talk about some exponent properties, or some rules, if you will. And if you won't, then we have a huge problem. So rule number 1, x to the first power is equal to itself. All right? Anything to the first power is just itself. It's Hono.
Oh no.
Oh no, Hono. Welcome. We're glad you're here. Honomeru. Honomo. Eru. Or backwards. Ure omona. Very good.
Oh no, do you want exponents?
Yeah, Hono, is there something in particular you want us to do? Because it's right now it's just kind of you. Rule number 2, x to the 0th is equal to 1.
Why not 3, my lord?
It's just 1. That's what it is. Oh no, let us know. Oh no, let us know, Honward. Okay. Good. Talked about that. Rule number 3. And now we get to some sweet properties. X squared times x to the 6th is going to be equal to x to the 2 plus 6, which is x to the 8th. All right? When you're multiplying two bases together that are taken to exponents, you want to add the exponents. Anything's fine. I have a killer headache today from a bad fall, so I won't be engaging. I'm sorry to hear about that. A bad fall. Hopefully it's a better spring.
No, but.
Sorry. Sorry if that... Hope you're okay.
Sorry if it fell flat.
What did?
The joke, but like also Hona may have fallen.
Right. Well, hey, we're here for you, Hona. That's why we're doing exponents, because we know that exponents are the best cure for headaches. Great. All right, so why does this make sense? Because you're just x times... Okay, so x squared. That's x times x. We're multiplying that by x to the 6th. 1, 2, 3, 4, 5, 6. Parentheses here do not matter. Everything's multiplication. We have 2 and 6, a total of 8 x's here. So it's x to the 8th. That's why we add these things. Great. All right. All right. Going down to number 4. X squared, in parentheses, to the 4th power is equal to, hey, Eric TLT is here. Yay, Eric, you're here. Woo! Guess where you're not? Not here. You're not here because you are definitely here. In this case, we're going to multiply and get x to the 8th. Eric, anything you want us to talk about?
Eric has 2 questions left over from last night, I think.
He does. On the Discord?
Uh-huh.
Oh, Eric, you want us to go over your questions on the Discord? We'll do it. Don't think we won't. The reason why this is happening, x squared is x times x. And if we take that to the 4th power, that means times itself 4 times. So it's this entire quantity times itself 4 times. If you look here, there are 8 x's now. 2 times 4 is 8. All right, Eric, let's talk about those problems. Let me get my problem generator, my iPad. It's an iPad mini. It is kind of old, but I like it. It does the job for me. I don't know why you're so against it, Eric. It's a fine device. Just calm down. Go into Discord here. Well, we're going to make some space here.
Oh, can I do this one?
Yes. What if I want to do it, though?
That doesn't make any sense.
You're right. I'm sorry. Getting rid of this.
I'd like to do it because I was doing the ones for him last night that are like this one.
Is it from UWorld?
Yes.
Are they linear equations?
Yes.
Do you like them?
Yes.
Do you want them?
Yes.
Fair enough. We're going to keep the exponents up here.
Okay.
I just carved you up a little space here.
Thanks, Bert.
Yeah, I mean, whatever, if you're into that sort of thing.
Yes.
So is it these last two? These are for comp.
Yeah.
Can I do at least one of them?
You can do the second one, I guess.
The bottom one?
Yes.
Got it.
Okay, so Eric, this one is sort of like what we were talking about yesterday, right? Where I had written up here
zero solutions, one solution, and infinite solutions, right? And infinite solutions means they're the same line. Zero solutions means they're parallel lines. And one solution means they just cross in one place because these are linear functions. So I'm going to write out the linear functions real quick. So negative 5x minus 4y. Negative 5x minus 4y equals 2a. And then 4x minus 5y equals 2. 4x minus 5y equals 2. Okay. We want to solve for a. Solve for a. And the answers are a is 0.8. A can be, so we're dealing with either a being 0.8, a being anything, a not being 0.8. There's a negative 0.8 in there. So we'll deal with that. So let's put these, as we did last night, in y equals mx plus b form so we can get a better understanding of it. So the first one, I'm going to add 5x and then divide by negative 4. So we get y equals negative 5/4 x minus 1/2 a. I'll write that as a over 2. That's probably better. Minus a over 2. The second equation, subtract 4x, divide by 5y, negative 5y, we get y equals 4/5 x minus 2/5. Okay. So this is an interesting situation. This is actually what we started with last night that got us going. We have this system of equations. We're looking for a value of a that gives us something where the lines will intersect at exactly one point. They could be like this, they could be like this, something like that. They won't be parallel, and they also won't be the same line. So we're basically done before we start. We have different slopes. If the lines have different slopes, they're not going to be the same line. They're also not going to be parallel. So we're done. It doesn't matter what a is. So the answer, I think, is a? Yes, answer choice A is a can be any number. Does that make sense? So I didn't draw any math up here aside from just putting them in y equals mx plus b form. But it's more understanding of this at its most foundational level of, okay, zero solutions means they are parallel, and the same line means they have infinite solutions, and one solution means that they have different slopes and they intersect. Great. So it's weird stuff, but if you see this and you're dealing with a number of solutions, think graphing and think putting it in y equals mx plus b form. Lovely. Bird, you got the next one?
Yes.
What?
Hey, did you hear that the ice in Greenland started melting a full month ahead of schedule?
That's good.
That's really good news.
So it'll arrive on time.
Yeah. Yep.
Plenty of time.
Usually pretty late, so it's great that it's starting up pretty
Ice
early.
in Greenland should probably watch. Can I erase this up?
Yeah.
Should probably watch the stream.
You think so?
Yeah.
Because it's
That much
early?
time on its hand.
Yeah.
Hands.
Does ice have hands?
Yes. Think Frosty the Snowman.
Got it. Can you get rid of that? Climate change. Eric TLT.
Can I get rid of climate change?
Could you?
Yeah. Why didn't you ask me? Nobody's asked me.
Oh,
Everybody complains about it. Nobody asks me if I can fix it.
Right, that makes sense. Well, hey, fix it. You doing it right now?
I feel caught.
Really?
Yeah,
You can't do it?
I can't do it.
So you could do it until someone actually asks you, and now you can't do
I
it.
thought I could.
Yeah, that makes sense.
Yeah.
Yeah, it makes sense. Hey, it's fine. Polar bears have to swim more. Yeah, I mean, polar bears were getting kind of fat. It's about time they, bulk up, get strong from the
Did you
swimming.
punch this?
No, I did this
Why was it shaking?
because of the fat. See?
Oh no, it's because
No, fat. See? That's why it's shaking.
Nope.
Leave the polar bears alone. Well, no, we got to take them to the gym, get them all worked out. We got to lose some weight. No, it's a huge problem, and we at Nerdwish are worried. But that is why we are educating the next generation, so that they can solve the problems that our generation hasn't been able to. We've had our shot.
Yeah, we're done.
We're done.
Yeah.
This is all we have
At
left.
17 years old, we're done.
Is that how old we are?
At least.
At least 7. Yeah, that makes sense. All right, this is the next question. We have a nice thick system here. We got 1/2 x plus 2/3 minus 1 is equal to 2 times y plus 1/3 minus 1/3. That is equation 1. X minus 2 minus 4 y plus 1/2 is equal to -2. That is our system. Consider the system of equations above. Which of the following statements about the system is true? And, okay, we can break this down into 3 main categories. There are infinitely many solutions, there is 1 solution, or there is 0 solutions. Levi hopefully gave you the scoop on what makes each of those possibilities happen. So we'll figure out which one of those is the case. Now, these equations right now are an absolute mess, and they're very unsimplified. So the first thing you're going to have to do is just simplify these things and get them into a form that we can look at and understand. So I'm going to start with the top one, where there's a lot of distribution we're going to have to do. So 1/2 needs to be distributed into this. So let's do that. That's going to give us 1/2 x plus 1/3. That's what 1/2 times 2/3 will be. Minus 1 is equal to, okay, distribute the 2. 2y plus 2/3 minus 1/3. Fantastic. Fantastic. Okay. So 2/3 minus 1/3 would just be plus 1/3. So I'm going to rewrite this as plus 1/3. Okay? The advantage to that is that we have plus 1/3 and plus 1/3 on both sides. So we can cross those out, leaving us with 1/2 x plus, nope, minus, sorry. 1/2 x minus 1 is equal to 2y. All right, that is a whole lot easier, okay? I think the easiest way to identify when lines are going to cross or not is when you put them in slope-intercept form. Because you can tell what the slope is, you can tell what the y-intercept is. If they have the same slope and they're parallel, then you know they're not going to be, they're not going to cross ever, and they're going to have 0 solutions. So I'm going to put this in slope-intercept form, and then we'll figure out what the other one's going to be in slope-intercept form. So we're really almost there. We just have to divide both sides by 2. And we're going to get y is equal to 1/4 x minus 1/2. Where did you get 1/3 on the left side? We have to distribute. So these are 2 different equations, by the way. I'm only working with the top one. That's where I started with. So don't worry about the bottom one. I distributed the 1/2 to the x and the 2/3. 1/2 times 2/3 will give you 1/3. You're taking half of 2/3, which is 1/3. Or you can multiply it out and see that that's where it comes from. Eric TLT, does that make sense? Distribute the half, multiplied by the 2/3, you get 1/3. Okay?
Flip the fraction, change the sign.
That's not in this case.
Oh.
Not in this
Flip the
case.
sign, change the fraction.
Very good, very good. All right, so this is the slope-intercept form version of the top equation. Now we're going to go to the bottom equation. So here we go. We have some distribution to do. So x minus 2, there's nothing that we need to distribute there, so that's just going to be x minus 2. We're subtracting minus 4y, and then minus 2. Negative 4 times 1/2 will be negative 2, so minus 2 is equal to negatron 2. All right, we have negative 2's on both sides, so we can cross those out by adding 2 to both sides. And then we have x minus 2 minus 4y is equal to 0. Let's solve this thing for y. Get it on the other side. X minus 2 is equal to positive 4y. Divide both sides by 4, and you get y is equal to 1/4 x minus 1/2, which is identical to the other equation. Hey! Janelle Mitzel Santoyo recommended Brianna Whitley watch again. Brianna, you should watch. For those of you on Twitch, we just had someone comment through our Facebook viewing, our Facebook Live. That's why you don't see it. But we miss you, Brianna.
Very exciting.
You are going to love the stream, and the stream is going to love you right back. These two equations are the same, which means if you graph them, you have two lines that are directly on top of each other because they are the same line. Therefore, you have infinite solutions because any one point you have on one line, you also have on the other line. They share all the same points, and these points go on forever. So you're going to have infinite solutions. Let's make sure. That is going to be C. There are infinitely many solutions. All right. All right, all right. Levi,
Yes?
what's next?
There is nothing.
All right, so back to exponents. Infinite solutions. That's right,
Yes.
Eric TLT. Infinite solutions. Can you wrap your mind around that? I don't think you can. I don't think you can. I can't either. Neither can Levi.
Nope.
Yep.
Go like halfway.
Infinity is a concept that humans, we're not meant to grasp. We're just not. It's okay. You shouldn't be ashamed. Eric, don't be ashamed.
Eric, we're out of your questions, so throw a couple more up in there.
Yeah, it's kind of fun.
Oh, I stood up too fast.
Dude, you shouldn't have fasted today.
You shouldn't have fasted today.
I didn't fast today.
Yes. Dude,
What?
dinner was good.
It was, wasn't it?
Yeah.
Isn't that steak fantastic?
Yeah.
I mean, that was unbelievable.
Yes.
And it's incredibly cheap.
Yes.
Yeah.
Well, how much did I pay? Do you remember?
I don't know what you
I
paid.
paid over $10. It's not that cheap.
I paid around $10 for for steak.
Well, I mean, it wasn't, still on the bone.
Do you like the bone? The
Yeah.
bone that's what it was rotating. I was rotating on the metal bone. And
Yeah,
you took
but
it off.
I like to sleep with the bone afterwards. Like I hold it like the T-bone thing
Yeah,
with the
yeah,
steak, and I just hold it across my
Like
heart.
it's like a vampire thing.
Yeah.
Yeah, that makes
Yeah.
sense. I need help with something else. That sounds like on like an automated phone call.
That sounds like a cry for help. I can see
Yes.
right through that.
Or press 6 if you need help with something else. Or say, I need something else.
Oh my gosh.
Oh,
just
you
wait.
think so?
Well, actually, maybe not. I don't know.
I wouldn't put it past him.
No.
Eric, what do you need, huh? What do you need? We got what you need.
You've got a great deal of what you need, a little bit about what you don't.
Right, but the ratio. My friend was talking about how he got a new app that helped with all his stress, but I'm still stressed out of all these tests coming up. I cannot find time to study.
Called it.
That's what Levi said you were about to say. Eric, you could probably advertise for Alta Ipsum better than we could at this point. But I guess it's time, isn't it?
I don't know if it's time.
It's pretty early in our stream.
Yeah, it's a little early.
Yeah. All right, well, we'll get back to that, Eric TLT. But let's just say that there is a great solution that you should just keep watching to find out about. Yeah. Okay. Okay. Back to exponents. I'm going to expound upon the exponent properties. Got it.
Why do we have the word expand and the word expound?
Is Eric just your reminder to the sponsor? Yeah, Eric is actually just a bot. That
From the sponsor itself.
From the sponsor itself. Yeah. We made up Eric. Eric, you're so excited. We love it.
Eric, post your questions in the Discord.
In the Discord.
Not this question.
Not this question.
Not this question, my lord.
In the Discord, my lord. My lord Discord. Dislord my cord.
Dislodge my cord,
Yes.
lord.
I will make your cord dislodged. Very good. Here we go. Next
So
one.
You discord it.
X to the 6th over x to the 3rd, no, to the 2nd, will be equal to x to the 6th minus 2 is equal to x.
Why not 3, my
To the
lord?
fourth.
Nope.
Because it's simply not 3.
Right.
That's why.
Most things aren't.
I don't have any right now. Well, get
Dang it.
some. Go buy some.
Right, what have you been doing?
Use
for the
your
last
bits. I don't know.
22 and a
I
half
don't
hours,
care where
Eric.
you get them, Eric. Just get them.
Find them. They're there.
What do you think we're here for?
Just do things that are hard on the SAT.
My dad's pretty hard on the SAT. He doesn't like it as a test.
Really?
Yeah. Well, forget it. We're going to keep going. We'll find some things that are hard on the SAT. Here we go. Here we go. So, if you think about why this is, x to the 6th is... I was watching your stream the last 20... What are you doing?
I wasn't doing nothing,
I
sir.
saw you do that.
No, I wasn't doing nothing.
You wasn't doing
I
nothing?
No, I weren't doing nothing.
X to the 6th over x squared. I don't have time. I was watching a stream the last 22 hours. We weren't streaming for 22 hours. You telling us you're just watching all of our streams? Are you able to comment on them and we answer them in the past? Because that explains why you're able to like constantly watch our streams.
Yes.
Yeah. Maybe there's some kind of a Twitch time algorithm that lets you ask questions that we then answer.
Uncle Bill! Uncle Bill, okay, so can you please set Eric straight?
A multitasker flies by. He likes that, doesn't he?
Yes.
Okay. 6x's on top, 2x's on the bottom. There's going to be some cancellations. Minor scheduling adjustments. What? This x will cancel out with that x specifically, not any of the other x's.
Yeah, don't do that one.
Yep, but this x is going to cancel out with that x.
It reminds me of this little piggy went to market.
It should. It should. Leaving us with 4x's on top. So to figure out how many are going to be left on top, we just subtract because that tells us how many are going to be canceled out, leaving us with 4 on top. Okay? Fantastic. We're all doing so well. What's the big problem? Everybody's doing it. It's great. I don't know. I'm getting excited. Next one. Now, this is not equaled. X to the negative 5th is equivalent to 1 over x to the 5th. A negative exponent just wants to go to the other side. That's all they want to do. Okay? That's literally all they want to do. If they're already on the bottom and they're negative, 1 over x to the negative 4th, they want to go to the top, becoming x to the 4th. Now, when I say the top, and I'm only writing one thing, there's an implied fraction here. Anything can be written as a fraction if you put it over 1. Okay? So, if you're negative on top, you want to bring yourself down to the bottom. If you're negative on the bottom, you want to bring yourself back up to the top. If you're negative on the left, I don't know, man. You're not right.
Why not 3? No.
There you go. That's good. That's good. Fantastic. Everyone's doing so unbelievably well. All right, some other things you got to know. You got to know them. If you don't think you got to know them, you would be wrong. Rule 7. This is a fun one. Okay. The square root of x is the same thing as x to the 1/2. All right? That is huge. A lot of times you're going to have things like, I don't know, the square root of x to the 3rd power. And you're going to be like, what do I do? What? Change the square root into a fractional exponent. Rewrite it. You've got x to the 1/2 in the inside, taken to the 3rd power, and now you just go ahead and use, bam, rule 4. When you got exponents inside and outside of parentheses, you multiply them, and you get x to the 3/2. All right? 2 plus 2. That's your question, Eric. Is that your question? Is that your question, Eric? Is that your question? Eric, is that your question? Is that your question, Eric?
Thanks for the host, Uncle Bill.
Hashtag Nerd Hype Achievement awarded. Hey! What does that mean?
Uncle Bill is hosting us.
So does that mean his viewers are watching us?
Yes.
Yay! Thank you, Uncle Bill. You've done more than you've ever needed to do for us. And you taught me how to throw a spiral when I was just a kid.
Yeah, Mom always talks about how you're her favorite brother.
Yes. This is similar. The cube root of something is that something to the 1/3 power. I think you're seeing a trend here. Sorry, that was obnoxious. So, let's talk about something. Let's take the 7th root of x to the 5th. This can be rewritten as x to the 5/7. Okay? The number that's on top is going to stick with the x. The number on the bottom is going to tell you what root you have. All right? This is x to the 5th, but we're taking the 7th root of it. It also means TFK tweets and Facebook posts are made. Oh. The Knowledge Fellowship. Bum ba da dum. Blow the horn. Ooh. Let the Knowledge Fellowship assemble.
Wait, maybe you gotta go find
Kind of like a wig. Circumference?
Yeah.
I think so. Can you hold off the? Can you chill on the stream for a little bit?
I mean, I can do more of this stuff.
Yeah. Just have fun. There you go. Your markers.
I got my markers.
Yeah, I think that's what needs to happen right now.
I think so too.
Okay, so Eric and Hono and anybody else watching, especially you, Uncle Bill, you got to figure this stuff out because this has been your biggest problem, I think. Putting these all together. So let's say that we have a to the -2. We're gonna have just a big old thing. Here we'll do that. We'll do that. We'll do 1 to the 8th, -1 to the 8th. And we have b squared cd to the -2. We'll have a 3 out here. We will put all of this to the -2 power. Then we also have a to the 1/3 and c to the -4/3. I would like this simplified. I'm just going to leave it here. You can do it on your own and let me know what you think the answer is. I don't know the answer off the top of my head because that wouldn't make any sense to know the answer for this off the top of my head.
Glasses or no glasses?
I think probably glasses, but we need a little space for you.
Sure.
Yeah.
Right.
Yeah. Bert, you can't make me laugh when you're not on screen because then I just look dumb.
I need to check stuff.
Okay. Thank you for the congratulations, Uncle Bill. Yeah, so we, for those of you who aren't Uncle Bill, we were written up in a paper in northern New Jersey, which is where I grew up. What a troll. What's the troll for? What's happening? I'm going to drop this stuff off the board here. Hopefully you know it.
Ha ha!
Not yet.
Ha ha!
What is that noise?
I can't stop.
You can't stop.
I can't. For I am Sir Conference. Blow the horn. You don't. I'm already here. You don't need to blow the horn.
Why did you tell me to blow the horn?
Because I like the horn. Ha ha! Would you like me to simplify this, my lord?
Yes.
Will you give me the hand of the princess if I do?
Yes. Princess Diameter
Princess Diameter.
will be yours.
Yes. And once I marry Princess Diameter, I will kill the king. But secretly, so they don't know it's me.
Just make sure Princess Diameter is not actually the king's queen and you their son. Cast out when you were very young.
And I don't realize that it's my family?
Yes. On your way here, did you kill a man at a road crossing?
Like a crossroads?
Yes.
Yes, but that's like every day for me.
Okay, so it's a pretty good chance.
Probably, yes.
All right.
Yes. Honomero, how did I get ripped so quick? What do you mean? I was always this ripped.
Intermittent fasting.
Yes. It's a very promising strategy.
Yeah.
Let Circumference handle this. Ha ha! Is this 1 or L?
1.
1 to the 8th?
Yes.
That's dumb. Circumference will take care of that. 1 to the 8th power is simply 1. -1 to the 8th power. Now this is interesting, because the 8 will be applied to 1 before the negative will be. Alright? So 1 to the 8th power will still be 1, but then we have a negative in front of it, leaving us with 1 over -1. Now 1 over -1 will just be -1. Hence, I will rewrite this and just say -1. Here we go. Look at that. Just made that into a negative. Ha! When I do exponent things, I feel strong. All right. I'm going to simplify what's inside the parentheses before I apply the -2. First, let's see what we have. All negative exponents will switch sides and go to the opposite side. So, the 3 is staying, but the 8 to the -2 will now be on the bottom. And it will become a to the positive 2. B squared will stay. C to the negative 4/3 will now be on the bottom and become positive 4/3. Ah! Look who it is! Please come. It is my compatriot, Bat Lion. Come on, Bat Lion. Come on out. Come on, Bat Lion. Don't be coy. I have a sword. Shing! There's a sword here. Are you not afraid? That's disgusting. Come on out.
I have nothing to contribute, though.
Very good. CD to the negative second. I will apply the negative second to both of them. A to the 1/3 will stay on the bottom. Now, as you can tell, I now have more negative exponents. What does this stream turn into?
Your worst nightmare. I'm Bat Lion.
This is Bat Lion. I am Circumference. Bat Lion is my trusty sidekick. He can help me get from place to place. I don't have a horse. I have Bat Lion. He can fly and ride. And he doesn't say much. But he says things sometimes. Say something.
Power rule.
Yes. Let me pull the string on his back and see what else he has programmed in him.
Quotient rule.
Ah. We'll see how many responses he has.
Hello, ho no.
Oh, that's fun. When is it going to repeat?
Hello, ho no.
Oh. So you got 2 of those in you.
Hello, ho no.
Oh, it's a question. He's not sure if it's Hono or not. I'm going to continue with this. The C and D are both going to be up on the top. So I will put them on the top and I will strike them from the bottom. Strike them like a king once you've married his daughter, the princess. So that you can be king. OML. On my life, that's terrifying.
Oh my lord.
Oh my lord. Hey! Do you know that person?
No.
Oh, why did you go? What? Do you know that person?
No, I don't.
Is
Hi.
Jella.
Hello, Gala.
Is it Jella or
How
Gela?
do you pronounce
Is
your
it
name?
Gayla? Is it Gila?
What do you need?
Is it Sheila? I don't think it's Sheila.
Probably not.
No, probably not.
Is there something you need help with on the ACT or SAT? Right now we're going over
Exponents.
exponents.
And I am Circumference. Ha ha! Okay, now, negative exponents have been dealt with
my
by my
favorite.
sword.
It's my favorite name.
Circumference?
It's all in the name.
It's very good. I will now attempt to combine like terms. B is taken care of. C squared and C to the 4/3 on the bottom. Very good. I will now subtract. 2 minus 4/3 will be 2/3. So I will rewrite this now over here. This will be 3b squared on top. C to the second minus C to the 4/3 is going to be 2/3. C to the 2/3. Good. Our B's and C's are taken care of. Our D's are taken care of. But it's our A's we must talk about. A squared times A to the 1/3. We'd add our exponents in that case, leaving us with A to the 7/3. Now we may apply the outer exponent. Ha-ha! You know, when I'm in a costume, I feel kind of like anonymous, but it's very easy to tell who I am. Yeah, he doesn't care. Anyway. To the negative second. Will apply to all of these.
Were you talking to me?
I don't know who I'm talking to. So the negative second will apply to all of these, so I will write that in now. We now have 3 to the negative second, B to the negative 4th, C to the negative 4/3, D to the negative 4th, over A to the negative 14/3. I applied the negative second to all of them. Eric TLT. Costume? Yes! It is a costume. Very good, Eric TLT. You're learning. Now, the negative exponents must be dealt with again, like a knave. I will rotate where they are. This will now be a to the 14/3 on top. That's the only thing on top. And now we have 3 squared on bottom. B to the 4th on bottom. C to the 4/3 on bottom, and D to the 4th on bottom. Apply the negative. Negative A to the 14/3 over 9 B to the 4th, C to the 4/3, D to the 4th. I thought that pack was real. This pack? Ha, no. No, it's not. Unfortunately, I wish it was as well. If I wanted to rewrite this in radical form, I would make this negative cube root of a to the 14th over 9b to the 4th, the cube root of c to the 4th times d to the 4th. I have simplified your foolish exponent problem, Master Leafward. Will you join me?
Yeah, I think might be a good time to answer this question. What is alta ipsum?
Here's your answer. What isn't alta ipsum? And the answer to that is most everything.
Very good. Alta ipsum means summit yourself in medieval Greek Latin.
Yes.
Which one?
There was a time when they were merging.
Right.
It was during that time that alta ipsum came.
Very good. And what did alta ipsum do when it came to the land?
Alta ipsum was a magic spell that cleared your head and made all of your accomplishments done. That's what it used to do. But then, since the dragons have now died, magic is no longer exists. But alta ipsum is now an app that you can get, and it's almost as good as the magic used to be. You can put it on your smartphone. You can put it on your computer. You can put it on your sword. Shing! I need a sword.
You do.
I need a sword badly.
No, I worry about you with a sword in your hands.
Really?
Yeah, because you're going to knock something over.
You don't know that.
I don't know that.
Well, I'm playing a knight that's been well trained. The knight wouldn't do that.
You're kind of brandishing your lack of sword pretty, foolishly, though.
It makes a noise. Did you hear it?
I did hear it.
You know what? I've been forgetting that I've had a sword. I just, stopped holding it, which is very bad technique. So if I pull it out, shing!
For your space object word?
I have to put it back in. Thunk. Shing! Thunk. Alta ipsum lets you organize your grades, goals, schedule, academics, all of it. It lets you outsource your stress about what's due and when to an app, and the app reminds you of when to do things. You want to write an essay? It automatically puts in 3 different events. Write the first draft. Edit. Final draft. On 3 separate days. Continue. You're not circumference. I'm circumference.
Didn't we cover everything?
Shing. It's free for a month.
Oh.
No gold doubloons needed for this magic spell for a month. 1 cycle of the moon. A month. That's where month comes from.
Does it?
Yes, a month. A lunar month is 28 days. Will you stop pulling at my skin? That's my skin.
I just want the peck to...
What do you want the peck to do?
I don't know.
Does anyone have any questions? We've talked about exponents. We've talked about my asking the princess for her hand. And subsequently killing the king. Shing!
Yeah, you're not getting a sword, dude. No sword of yours is coming anywhere near this board.
Funk. Oh. Do we have a sword?
Yeah,
Where is it?
it's in my room.
Really?
Yeah,
Oh.
in my office.
Your office. Yeah. That's a laugh. Oh, very good. Random
Random SAT stuff.
Correct. That is the answer.
We can do some random SAT stuff.
Oh, that's what he wants.
What did you think?
I don't know. Should we talk about... Oh!
Whoa!
Should we talk about circle sector areas?
Well, Hono's got a question about the essay. You had a question. Do you still have it?
Yes, or did you lose it?
Where did you place it?
Did you lose it during the war?
Is it with Rachel?
Where is Rachel?
Oh, also, my teacher didn't grade my essay because I wrote it in cursive and said I can't do it. Is that true?
Your teacher can't read cursive. That's why.
No. She's asking, can you write in cursive on the SAT?
Oh,
I
don't know.
I will look that up.
Yes, you will. You
But I'll know
how?
the answer before I look it up.
You're gonna what?
No.
I am circumference. Watch me flex. I will be the true king of whatever country I currently live in. Because I have a sword. Come on, guys, ask some questions. You think I like doing this? I don't. I'm only doing this for you guys. So how was everyone's day? Yeah, great. You want to know how my day was? I started the blacksmith because I was supposed to pick up my sword today, and he wants one more week with it. Will you turn that off? Anyway, the blacksmith wants another week with my sword, and I have a joust coming up. I don't need the sword for the joust, but once you're dehorsed, it turns into a sword fight. I'll have to use one of my page's swords. Not excited for that. Random SAT stuff. How random do you want it to be, Eric TLT? We can go very random or very not random. They used to call me the Prince of Random. Mine was fine. I missed a jump in figure skating practice and almost smashed my head fun. Do you have a head fun? I thought those body parts were extinct.
Okay, Bert, I got it for you.
What do you got?
I'm going to draw you a problem. It has to do with circumference. Can you hold this, circumference? I know you don't know what this is. Don't worry.
It is a seeing stone.
Flip the fraction, change the side.
I will do such a thing. Ah, a dunce cap. Oh,
It's actually what the witch doctors wore.
yes.
The little face thing.
That
I don't know
isn't
what
a
that's
dunce
called.
cap.
No,
No.
I know.
That was to avoid the plague.
Really?
They did not understand germ theory in the slightest. I literally can't wait to solve this. It's what circumference was born for.
LN.
Length of. I learned my letters when I was 10. Very good. Very good.
LM and NM are both tangent to circle O.
Of course they
O
are.
is the center
Yes,
of
they
the
are.
circle.
Yes, they are. Well, if they truly are tangent to the circle, as you say, they will make right angles with the radii that they touch. Because tangent lines make right angles with the radii that they touch. The next thing is that these are in fact two radii. They will be the same length. Same length, same length. The next thing, the circumference, in fact, which is, they named it after me. circumference, because I like circles so much. Circumference is normally 2 pi r, which in this case is 96. Let's solve for the radius. We divide by 2 pi. That is going to give us r is equal to 50, 49, 48. 48 over pi. That's what our radius is. 48 over pi. 48 over pi. What a good spot of fun. So we're trying to find this length right here. Is that the best you can do? Ha! Well, what I see is a four-sided shape. N-O-L-M. Nolm. It's a four-sided shape. Hence it must contain 360 degrees, but betwixt its four angles. We already have 60. We have 90. We have 90. The last angle must add up to 360 with the rest of those. So we're going to call it theta. What we know, theta plus two 90-degree angles plus 60 will give us 360. Theta plus 180 will give us 300. I subtracted the 60s. Theta is going to be equal to 120. 120 degrees. If I'm not mistaken, that is 1/3 of a circle. 120 over 360 is 1/3. Therefore, this arc length will be 1/3 of the circle. It'll be 1/3 of 96. 96 times 1/3 will be 32. Which makes sense because water freezes at 32 degrees Fahrenheit. And if you look at these letters, they are part of the alphabet, which contains the letter F. Donezo. I am circumference, this is my sword, Shing Funk. Top of the night.
Oh. Wait. Questions on it? Did you already ask if they had questions on this? I assume. Wait, did you figure it out?
Yes.
What's the answer?
32.
What was that? Oh, you dropped the chainmail. Very good. Oh, okay. No more circumference. Okay, Eric, you want random questions? Let's do. Yeah, we're. Nice. Bird.
Yeah.
Eric had a solid sign off or farewell to you, or to circumference.
Ah. Well, he's gone now, but I'll tell him you said that. He sounds so sad, doesn't he?
Any questions?
You're getting better at the ACT and SAT.
Okay, Eric, let's do some more math, huh? Ooh, maybe I can... maybe. No, I don't know if I can do that. Yeah, I figured that might be happening.
They're arguing about politics. This one won.
All right, Bird. I can't focus. You're making the chickens fight.
Sorry.
Let's do.
This?
Yeah. Just pull up the old question, something. That's kind of fun.
Yeah.
Okay.
You find something good?
It reminded me of something I was doing with my student yesterday. Yesterday? Yesterday. Yes, it was yesterday. Okay. Here's our function f of x. Okay? And I would like to know how to graph g of x if g of x equals negative f of x. Okay? So, we're given f of x. Now we're asked, knowing that g of x is equal to negative f of x, what would g of x look like if we graphed it on here? So I'll give you a couple of options, I guess. Just make them small. So let's say that's g of x. That's g of x. Or that's g of x. Which one is, I mean, these are all very poorly drawn, but which of these, A, B, or C, would be a g of x given that g of x is the opposite of f of x? This is like a negative cosine graph. Sort of. Cosine continues to oscillate, right? Because it's got an amplitude of 1.
Yeah.
But this goes up. Yes, C, because we're doing the opposite, right? So g of x, f of x, these are y values, right? So if we're taking the opposite, we're just saying, you know, if g of x is or if f of x is x cubed, which this is not quite, but if it's x cubed, then g of x is going to be negative x cubed. So negative x cubed would mean we're just taking the opposite value. So all the y values are different. So when we hit the x-intercept here, those will remain the same. Everything else gets inverted because your y value has switched. So that would be g of x. Good, Eric. Okay, same graph. Now let's do a bit of yellow. Can you see that? You can kind of see the difference, right? Okay, now let's do h of x equals 2f of x minus 3. What does that look like? Or tell me how to draw it. You know, what if any points are the same? Can you tell me where points are? I'll give me a sec to erase this, and I'll draw a couple of options.
Oh, are you gonna draw a couple of options? Is that what you're gonna do?
Yeah, I just said I'm gonna do it.
Yeah, sure. I'll believe it when I see it.
We don't condone violence.
Good. That's all you gotta say.
Would it be stretched and down 3? Perfect. Yes. So I'm not going to draw options. I'm just going to draw what Hono said here. So yes, it's going to be stretched because your y values are doubled. If you're not quite comfortable with f of x being y, that's just what it means. If you have f of x or g of x or h of x, it's y when x is some value. So if you're doubling the y value, you're stretching it, right? Instead of, if you have the point 1, 1, then now you'll have the point 1, 2. If you have the point 630, now you have the point 660. So this is yellow. So it'll be the same as the f. We're going to sort of have the same x-intercepts, but those are all going to be moved down 3. So let's say that that's 3, whatever. And then it's going to be stretched. So that means it's going to go up higher, go down lower, and then have a more extreme slope. It would look something like this. Good, Hono. Very good.
There's a lot of good questions in here.
Yeah.
I don't know why we haven't been using this. Like, I just don't understand why we haven't been using this.
You don't? Any questions on this at all? Or any questions of your own? I'm going to erase that in a sec. Ew, that line is ugly. We can do... do I want to do that? No, I don't want to do that. Let's do something different. Hey, Bird, can I see that book again?
Yes.
Is this all math?
Yes.
Whoa. Any questions, anybody? What was the no for? I don't know what the no is for. Sorry. Oh, that's fun. Okay. We have a circle. We have a rectangle that is inscribed in the circle. Let's say this is length h. So we're given that h equals 16. We're given that the area of the circle is 100 pi. And we want to find the area? Yes. What is the shape? What is the area of the rectangle? Area of rectangle equals what? That's what we're going for. So we're given that the height of this rectangle is 16. We don't know the width. Can we figure out the area of that rectangle?
I doubt it.
Bird? Who knows? You asked if I knew what alta ipsum was. Did I? Oh. Well, you don't know what... I genuinely don't remember asking that. So, gonna just move on, Eric. Do you know how to find the area of this rectangle here? Or Hono, or anybody else?
Perhaps circumference?
Circumference is gonna stay. He's got to kill his father, or his king. Oh, Freudian.
He has to
Oedipus
marry the
slip.
princess first. Otherwise, killing the king will be for naught.
Okay. So we know the area is 100 pi. So let's use this to figure out other stuff. We know that the... You asked what? Oh, you're making a joke that I didn't pick up on. Got it. Cool. Glad you don't have any questions. Good. How are we lagging a lot? Whatever. Okay. From this area, we can figure out what our radius is. So we know that this has to equal... Again, okay, so let's start at the beginning here. We're given the height of this thing. We're asked for the area of this rectangle. And we're given this other thing. So clearly we're dealing with circles. We're dealing with areas of rectangles. So we need to find the width, right? Once we find the width, then we can just multiply it by the height. We'll find the area. There is no other way to find the area of this rectangle. Because you don't know what these things are. They're not semicircles, so you can't, they're not a particular portion of the circle that you can figure out. So we're going to have to find W. Now, we don't know how to find W. Here's the deal. With circle geometry problems, if you are given a circle, draw in radii. The radius is the most important piece of the circle. It tells you everything else you need to know about it. Maybe not its location in space, but you know the circumference, you know the area based on the radius. So we know the circumference here, so let's work backwards for the radius. This has to equal pi r squared, so that means that r equals 10. This is good to know, because now we need to draw in our radius, okay? And I don't know to do that because that's just what you do, except that I've done enough of these problems where I've realized that we're just going to draw in a radius, because you draw the radius from the center, obviously, to a point that seems to matter. So we're not going to draw it to here. There's no point.
There is a point.
There is a point. I did just draw a point. We're going to draw it to an important point on the edge of the circle. So let's draw it to here. That's a radius, and it has a length of 10. Yeah? Then we also have, we're trying to find the width. So you can realize, or you have to realize, that you have a right triangle here. And you know that the height is 16. So if this is 16, then, and that's the whole height, then starting from the center of the circle up to here will have to be 8. You can do Pythagorean theorem to find that length of this right triangle. It will be 6. So it'll be 6 here. You'll have another 6 here. So therefore, the width equals 12. So the area of the rectangle equals 16 times 12, which is 192. 192, whatever units squared. Where did pi go in yellow? Pi went away because we have that the area is 100 pi. And how do you find the area of a circle? You do pi r squared. So now this is our equation, just right here. 100 pi equals pi r squared. So the pi just cancel. Then you have r squared equals 100. So you take the square root of both sides, you get r equals 10. It's all about equations. All about equations.
Oh, that's great.
Bird, you're talking to me, not Hono.
Oh, okay.
Any other questions on this? This is a very good problem. It's the recognition is I'm dealing with shapes. We like triangles and we like circles because those are the most basic shapes of their realm of things. Circles are just kind of in their own thing, and then triangles are the best polygon to be dealing with because everything else is based on them. So you're always looking to make triangles. A lot of the time, drawing in a radius for the circle will help you build a triangle, which will then help you solve the problem. Let's do another one similar, or not similar to this, but where drawing in a radius will help. I'm going to forget how to do it. Yes, you don't have to know how to do this problem right away every time. What you need to realize is you're going to be labeling everything, and then you can sometimes work backwards. That's what I did to an extent here, because I knew we had to find the area of a rectangle. So there's only one way to do that. So I have to find the width. Okay, that's sort of a dead end when I'm going backwards. I have a circle. With circles, you draw in a radius. Do that to an important point, see what it gets you. Look to build triangles, look to build other circles, things like that. The radius will help, I promise. We'll do another one, and then you can tell me where to draw in the radius and see what happens. Yeah, it's totally fine to forget how to do the problems. You don't have to know, I mean, you need to know how to factor immediately every time. But you don't always know that you have to factor. There is a recognition thing that you do that I think you should remember for when to factor, which is I can't combine my x terms, because I have an x squared here and I have an x over here, so I'm going to have to factor. Or I have an xy here and an xaz here. I can't put them together because they have other variables stuck with them. Therefore, I'm going to have to factor out the x. So it's recognition as you go through problems. there is a ton of math on the SAT. There's a lot of stuff you need to know. You don't have to know how to do the problems every single time from the outset. I'm almost done. Pac-Man chasing a zombie. Pac-Man chasing a zombie.
That's what the eraser pattern looked like. Look at your Pac-Man. Your erasers.
What?
No. Look at the residue on the board. You're about to hold on, stop.
No, I know.
That looks like Pac-Man.
Yeah. Zombie?
That you
Is
already
it a
erased
zombie
it.
or a ghost? Okay, next. That's a chord. Chord A, B. Okay? This is circle O. And let's say that AB, you're given that AB equals 8.
Why not 3, my lord?
It can't be 3 because I said it's 8.
Oh, that's the only. Okay.
Yes.
Sure.
AB is 8. And the circumference of the circle, or circumference, is 25 pi. What is the distance between chord AB and O? So that's the center of the circle. So when you're doing this, it's if you have a line and you have a point, it's going to be the shortest distance. So it'll be from the point straight to the line. It's not going to be this distance here or this distance here. It'll be the shortest distance between the point and the line. Kind of looks like a bridge. So, Eric, or anybody else, we're looking for the shortest distance between this point and this line. And then we have a circle, and we can maybe figure out the radius of the circle. So I would say figure out the radius of the circle. Tell me what it is. If I wanted the circumference, then this should have been 10 pi. Sorry. This is 10 pi. I would like to know the distance between AB and the center of the circle. This is not super well drawn. So tell me what the length of the radius is, and then tell me where you want to draw in a radius so that you can solve for this question. You don't have to know how to do this off the top of your head, but remember, draw in a radius to an important point on the circle. Is it 3? Look, Hono, answer my question. Don't answer this question. Yes, it's 3. But where do you draw in the radius? Because that's what I want you to practice. R equals 5. Good. So let's put that in. This tells us that the radius, normally denoted with a lowercase r, just so you know, r equals 5. That's nice. Cool. From O to A or B. Okay, let's do it to A. So we have that, and we know it's 5. What's next? and spirits. Oh, I'm gonna sneeze.
Be careful, my lord.
Yes, my lord. Yes, my lord.
Don't sneeze, my lord.
To the midpoint. Yes.
You'll
Lovely.
spread the plague.
So we're drawing this, and because it's to the midpoint of the chord, from the center of the circle to the midpoint of any chord on the circle will be, does that make sense? Yeah, will be perpendicular. Also, the shortest distance from any point, or from a point to any line. Good, yes. So, we want to find out what this is, right? That's our distance, D. And then we know that because AB is 8, and we've just gone to the midpoint of this is 4, meaning that D has to be 3 by Pythagorean theorem or Pythagorean triplets. Good. Perfect. You get 3. Okay, so this one was a little simpler than the last one, but it's always, whenever you see circles and there's something drawn for you, or even if it's not drawn for you, draw in a radius from the center to an important point, see what happens. That's probably how to do the question. Don't have to know exactly how you're going to get from the question to the answer, but this is a good place to start.
I'll say.
You will say. Ooh.
You're doing the Lord's work, Levi. The work of the Lord.
The feudal lord.
No, you know, God.
Oh, yes. What formulas? Like Pythagorean theorem? Pythagorean theorem's on the formulas page, right?
I don't know.
I actually don't know. I mean, I know the special right triangles are on there. I don't know if that's 30, 60, 90, 45, 45, 90. So the special triangle ratios, but the Pythagorean triplets that are very common.
It is not on the formula sheet. Simple Pythagorean theorem is not on it.
Okay. But circumference, yes, circumference and area are on the formula sheet. You can just also Google SAT formula sheet. It'll show it to you. Or it's on all the tests as well. We can do...
I like this book, Levi.
You do?
Yep,
How come?
it's got great problems in it that we can't just come up with ourselves.
That's pretty cool.
Yes, it is. I think we should probably just have like overlays of questions from this book from now on.
Okay.
We'll speak about it. Not
Yeah.
now.
Okay.
Not now. Would you like me to take over for a while?
Yeah.
Very good. Very good.
Got 15 minutes left.
Yeah, why not?
Hey.
Yeah.
How's it going, kids? Well, they're a bunch of kids.
That's true.
You guys are just a bunch of kids. That's all you guys are.
All right. Let's do a fun question here. Oh, this is awesome. This is so cool. All right. Volume of a rectangular prism is 1,080 cubic centimeters, or centimeters cubed. Okay. Length to width to height is 2 to 4 to 5. The question is, what is the surface area? Oh yeah, that is a loaded question. Very loaded. We're going to talk about it. Fantastic, fantastic. All right, let's get down to the bottom of this thing here. Let's draw ourselves a rectangular prism. All right, we got this, 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 this. One of those numbers. Fantastic. Bam, bam. Okay. The ratio of length to width to height is 2 to 4 to 5. Okay. Now, which one the height is, which one the length is, which one the width is, it doesn't matter as long as you're just consistent with it, okay? So clearly, they have this h, which is 5, which is the longest one. So let's put a 5 there right now. We'll talk about that if that's the appropriate thing to put there in a second, all right? The shortest dimension is 2, and then this middle dimension would be 4, all right? 2, 4, and 5. Would that give us the right volume? 2 times 4 is 8, times 5 is 40. No. There's something we can do here, though. Because 2 to 4 to 5 is the ratio we want to use, but clearly it's not just going to be those numbers, 2 to 4 to 5. A ratio is simplified. It's just like a fraction. They want to pull it down to the smallest whole numbers they can, but it doesn't mean that the actual numbers are 2, 4, and 5. They might be double. They might be 4, 8, and 10. We just have to figure that out. So here's the shortcut. You want to put x's on each of these numbers. So 2x, 4x, and 5x. The x is the multiplier. The x tells us how much bigger these numbers are than 2, 4, and 5. And we're going to use that because we know that the volume is 1080. So normally for volume, we do length times width times height is equal to the volume. So let's do that. We have 2x times 4x times 5x is equal to 1080. Simplify. 2 times 4 times 5 is 40. X times x times x is x cubed is equal to 1080. Simplify. We can divide by 10. We get 4x cubed is equal to 108. We can divide by 4. We get x cubed is equal to, okay, here we go. Divide both by 2. We're going to have 54 over 2. One more division by 2, and we're going to get 27. Take the cube root of both sides. You're going to get x is equal to 3. All right? So now that x is equal to 3, we know what each of these side lengths is going to be. 15, 12, 6. 6 times 12 times 15 is going to give us 1,080. I'm pretty sure. I mean, it will. You just got to trust me here. All right, now we got to find the surface area, okay? Now, the surface area consists of 6 rectangular surfaces, some of which we can see, some of which are behind the image we're looking at. Normally, you draw dotted lines to show the faces behind. But keep in mind that this face right here is going to be identical to the one that's on the back right here. All right? So each side is identical to the one that's directly opposite that. So you can find 3 different sides and then multiply all of them by 2, and you'll account for the sides opposite them, and you'll be good. This first rectangle is 6 times 12. All right? 6 times 12 is going to be 60 plus 12, which is 72. Okay? Next, let's do this side here. This long side, which is going to be 15 by 6. So 15 by 6 is going to be 60 plus 30, which is going to be 90. And then we have the top. That is the last one. And the top is going to be 12 by 15. 12 by 15 is going to be equal to, here we go, this is it right here. 12 times 10 is 120. 2 times 15 is 30, so this is going to be 150. But there are 2 identical sides for all of these, so we have to multiply all of these by 2. So we get 144, we get 180, and we get times 2 is equal to 300. This marker is squeaking like a mouse. Add up all of these areas. We have 4, we have 2, we have 3, 4, 5, 6. 624 centimeters squared should be our area. And I completely lost the page in the book that I was at, so you just kind of have to believe me. Sorry. Any questions on that? Let me know. Let me know, let me know, let me know. Here's another fun one. All right. How many positive 4-digit numbers are there with an even digit in the 100th position. And an odd in the tens position. Isn't 12 times 15 180? 120 plus 2 times 15 is 30.
12 times 15 is 180, yeah.
Yes, it is. Yes, it is. I said 150. Oh, man. 120 times 10 is 120 plus 30. Wait, Levi, what am I missing here? 10 times 15 is 150. That's why. Oh, jeez. I did 10 times 12. Yeah, this is 180. Here we go. 180. This is going to be 360. So we're going to have another 6 here. So that's going to be 10, and this is going to be 18, plus another 1 up here, because that would have been 18. 684. Yeah. 684. I apologize. Sorry about that. Thank you for being on top, Hono Miro. So we have 4 slots here of options. Each of these slots represents the number of options that could be in those digits places, okay? 4-digit number. There is an even digit in the 100s place. All right, so here's the 100s. Here's the 10s, the 1s, and the 1000s place. All right, an even digit in the 1000s place. Sorry, in the 100s place. How many even digits are there? Single digits. 2, so we got 2, 4, 6, 8. We can't use 10 because 10 is a 2-digit number. We can only put single digits in these slots. So 2, 4, 6, 8, that's 4. So we're going to have 4 options right here. These are all going to represent the number of options we have in each slot. So there are 4 options there. And there's an odd digit in the tens position. So how many odd digits do we have? We have 1, 3, 5, 7, and 9. That's 5. We have 5 digits we can put in here. All right? How many digits can we put in the ones place? There's no restriction here. We can put any digit we want in there, and there are 10 digits. There's not 9 digits because there's also 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 digits. We can put 10 digits here, and there's no restriction on the 1000s, right? Let's put 10 digits there. No. There's one we can't put there. We can't put 0 there. If you put 0 at the beginning of a number, it doesn't do anything. So the number would just be, 3 digits. So we can't use 0. We can use 1 through 9, though. So there are 9 digits here. The number is not 9,405.10. We multiply all the different options together. Okay? So we're going to have 9 times 4 is 36. 5 times 10 is 50. Let's not screw this up, Richter. 30 times 50 is going to be 1,500. 6 times 50 is going to be 300. So overall, there are 1,800 numbers that we could create here. And that is not an option. Ha-ha! Circumference, where are you? An even digit in the hundreds position. 2, 4, 6, 8. Yes. An odd digit in the tens position. 1, 3, 5, 7, 9. Good. There are 10 digits you could put here. And this needs to be, there's 9 digits here. 9 times 4 is 36. 5 times 7 is 50. 36 times 50. Levi, what am I missing?
It's just these 4 numbers multiplied together.
Ah, Hono coming in again. That's, wow, great. 0 is an even number, right?
Yeah.
So we actually have 5 options here. We can have 0, 2, 4, 6, 8. Hono, I don't know what I'd do without you. We're learning together. Great, so this is going to be 45 times 50. 40 times 50 is going to be 2,000. Hono, are you sure that you don't want to just do this and be on Twitch? Because you're crushing it right now. 2,000 plus 5 times 50, which is 250. So this should give us 2,250. And that's an option. And that's right, hopefully. I think that's probably going to be right. Okay. Ha, what is intelligence? Ha. Yeah. Yeah, you should be my ex-wife. I don't have one. All right. Levi, what time we got?
9:27.
Oh, I like that time.
Mm-hmm.
It's a very good time. Levi, do you ever wish you were a werewolf?
Yeah.
Sometimes I wish you were a werewolf.
Why?
I don't know. It'd be really cool. Like, oh, I have a friend that's a Levi. That's a Levi. I have a friend that's a werewolf. Like, I want to be able to tell that story at parties. Because I want people to think that I'm interesting, and people that have werewolves as friends are typically perceived as interesting. In my social research, at least. So if you could just get on that, that would be awesome.
On it. Boy.
Oop, a little bit of this. Sorry.
I'm so thirsty.
You're not drinking enough water. You gotta drink more water. Good. Eye contact is good when you're drinking water.
Water? Water. I don't need it. Water.
Bum, 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 bum.
Sandy, I need water.
Okay, let's maybe do one more problem.
Yeah, that'd be fun.
Ooh. Let's see what we got here. What we got here.
Yeah. Yeah, what we got here. That's kind of cool. Ha 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 ha. What do you got? We don't condone violence. We don't condone violence. We don't. Don't think we do. We don't condone it.
I feel like it's condoned.
No, it's not.
It seems that way.
But we don't condone it.
Ow.
That looks like a good one.
Yeah?
Yeah.
Ooh, that's fun. Okay, last problem of the night, unless anybody watching wants to ask one of their own. Gotta feed myself, bird.
Good.
It's the worst type of feeding.
Yeah.
Okay, we got a circle. We got oh boy, that's a circle. That's a better circle. It's an even better circle. Okay. And okay, so these three circles, the little ones, lie on the diameter of the big circle. And I would like to know what the what the area of the shaded region is if the diameter, say, diameter AB equals 12. The length of that equals 12. So, how do we figure out what the area of the shaded region is? This is one of those classic polygon inside a polygon things, although these are circles, and you just find the area of the big stuff and you subtract the area of the little stuff that you need to take out, and you're left with the shaded region. Because obviously you don't know how to find the area of this thing. There's obviously no thing for that. So you can look at the front of the sections in the math section for the SAT, or just have it memorized for the ACT. Area of circle is pi r squared. So let's say area of circle 1, which is going to be the big circle, equals pi r squared, so pi times 12 squared, which is 144 pi. And then we need to find the area of the smaller circles, so A2. So this is 1, this is 2, 3, and 4, those circles, respectively. So A2 equals A3 equals A4, right? They're all the same size. because they're 1/3 of the diameter of, or each of their diameters is 1/3 of this diameter. I've made a huge mistake. Hey, Bird,
Yeah.
you need pi for energy. Also, I made a mistake. Shouldn't be 144 because that's if the radius were 12. The radius is not 12, the radius is 6.
I need pi for energy.
You need pi for energy according to Stephen Misko.
Oh.
So that's 6, it's going to be 36 pi.
Huh. We talking about like pi 3.14, Stephen? Or are we talking about like an apple pie? Because, or is it both? It's like an apple 3.14. 159265535 8979323 8462 664 338.
You missed, there's a 3 and then it's a 28, not 338. Look it up.
No. Steven!
Steven. Okay. So the diameter of each of these is going to be 1/3 of 12. So the diameter of each of these is 4. So the radius of each of these is going to be 2. There we go. It's not a great 2. So the area of all of these will be pi times 2 squared, which is 4 pi. You have 3 of them though, so you have to do 36 pi. This is the area, the big area. So area equals 36 pi minus 3, because you have 3 circles at 4 pi area each. So it's going to be 36 pi minus 12 pi, which is 24 pi. I'm good with my business.
That's a lot of pi. Steven, you left a little 2 in there. 926. 3.141592. But hey, you know, who's counting besides people that design rocket ships that you just basically killed the astronauts with your lack of pi precision.
Anyway, I think we're good. What am I supposed to do with that?
Tell them.
Is it like a bagpipe?
Tell the people. No.
Oh.
Tell them.
I think we're good.
Yeah, we're good. Everybody else good? You seem good. You look good.
You smell good.
Mm.
Smells like vinegar.
You do.
It's a cleaning product.
You all smell like vinegar.
Yes. Strange. Very curious.
Our viewers have something in common with our light board.
Very curious.
Very cute. Yeah.
No, definitely not.
Oh, no. Definitely
The
not.
phoenix whose feather gave you this wand gave only one other feather. And it's curious to me because the owner of the wand of that one other feather gave you that scar. Hey! All right, we're out of here.
Have a good night, everybody.